There are two types of quantities. First type are called scalar quantities and the other are called vector quantities. What's a scalar quantity? A scalar quantity has something called as magnitude. And what is magnitude? It's something that has a numerical value. It gives a sense of quantity, or in other words, it tells us how big or how small something is. Even if you may not have heard this term before, you've actually used it since you were a child. Because we all have been using numbers since the beginning, and numbers are the best example of scalars. When we count something, for that we use numbers, which have only magnitude or only value. A quantity which has direction as well as magnitude is a vector quantity. These quantities cannot be described by a single number. A simple example is the motion of an helicopter. We must say not only how fast the copter is moving, but also in one direction. So when a physical quantity is described by a single number, we call it a scalar quantity. In contrast, a vector quantity has both a magnitude, which is the how much or how big part, and with that it has a direction in space. A few examples of scalars are time, temperature, pressure, energy, and mass. How are they scalars? Let's take example of time. When we want to specify what time it is or how much time has elapsed between two events, then all we need to specify is a number. We don't need to say the direction, and that gives us the complete picture. For measuring temperature of a body, again, we need only a number like 30 degrees Celsius or degrees Fahrenheit. The rest of the examples can be understood in a similar manner. For vectors, the simplest example is displacement. Displacement is a change in position of an object. Displacement is a vector quantity because we must state not only how far the object moves, but also in what direction. Walking a kilometer on a plain road towards east, and from the same place walking a kilometer on an inclined road towards northeast doesn't get you to the same place. These two displacements have the same magnitude but different directions. We usually represent a vector quantity such as displacement by a single letter such as A. We always draw a vector as a line with arrowhead at its tip. The length of the line shows the vector's magnitude. We usually represent the magnitude of a vector quantity by a vector symbol with vertical bars on both sides. The magnitude is a scalar quantity. That is, it's a number and is always positive. The direction of vector is shown by its arrowhead. If two vectors have the same direction, they are called parallel vectors. If they have the same magnitude and the same direction, they are equal, no matter where they are located in space. Note that a vector can never be equal to a scalar because they are different kinds of quantities. The expression a vector equals 6 is just as wrong as the statement 3 apples equals 4 mangoes. A vector can be shifted without changing its value if its length and direction are not changed. When two vectors a and b have opposite directions, whether their magnitudes are same or not, we say that they are antiparallel. Now it's important to understand how operations work on vectors. For example, addition. How do we add scalars? For that, we just need to add two numbers, like 1 plus 1 equals 2. But that's not how we add two vectors. Vectors must be added in a special way. There are two different methods to add vectors. The first one is called head to tail method. To understand this method, consider an example. Suppose you decide to take a hike along a trail through a forest. Along the path, you move from a point P1 to a second point P2 and then to a third point P3. A vector A represents your displacement from P1 to P2, while vector B represents your displacement from P2 to P3. These displacement vectors depend only on the endpoints and not on the actual path taken. Your net displacement from P1 to P3 is a new vector C and is called the sum of the two successive displacements A and B. The sum of two vectors is called the sum, vector sum or resultant. The plus sign in this equation and the words like sum and add have different meanings for vectors than they do in the usual algebra. Here it actually refers to a process called vector addition, which is a geometric process that takes into account both the magnitudes and the directions of the quantities. To add two displacement vectors graphically, we move the second vector without changing its direction or magnitude and keep its tail at the head of the first vector. A vector is then drawn from the tail of the first to the head of the second. This is called the resultant vector. This method is also called triangle law of addition. The tail to tip method of adding vectors can be extended to three or more vectors. The resultant is drawn from the tail of the first vector to the tip of the last one added. An example is shown. For adding three or more vectors, this method is called Polygon law of vector addition. Second method of adding vectors is called the parallelogram method. It involves drawing the vector B so that it is tail to tail with A, and a parallelogram is constructed using these two vectors as adjacent sides. The diagonal C of the parallelogram represents the resultant sum of vectors A and B. But how would we subtract two vectors? For that, given a vector, we define the negative of this vector to be a vector with the same magnitude as that vector but opposite in direction. Note, however, that no vector is ever negative in the sense of its magnitude. The magnitude of every vector is always positive. The minus sign only tells us about its direction. We can now define the subtraction of vector v1 from v2 as the sum of the vectors v2 and minus v1. An important question here is that what is the magnitude of vector addition? It's a common error to conclude that magnitude of C equals magnitude of A plus magnitude of B. In general, this conclusion is wrong. The magnitude of A plus B, besides depending only on the magnitudes of A and B, also depends on the angle between A and B. Only in the special case in which A and B are parallel is the magnitude of C equal to the sum of magnitudes of A and B. When the vectors are antiparallel, the magnitude of C equals the difference in the magnitude of A and B. For example, if a person walks 8 kilometers east one day and 6 kilometers east the next day, the person will be 8 plus 6 kilometers, which is 14 kilometers east of the point of origin. We say that the net or resultant displacement is 14 kilometers to the east. If, on the other hand, the person walks 8 kilometers east on the first day and 6 kilometers west on the second day in the reverse direction, then the person will end up 2 kilometers from the origin. So the resultant displacement is 2 kilometers to the east. In this case, the resultant displacement is obtained by subtraction. 8 minus 6 equals 2 kilometers. But what if a person walks 10 kilometers east and then walks 5 kilometers north? These displacements can be represented on a graph in which the positive y-axis points north and the positive x-axis points east. On this graph, we draw an arrow labeled D1 to represent the 10 kilometers displacement to the east. Then we draw a second arrow D2 to represent the 5 kilometers displacement to the north. After taking this walk, the person is now 10 kilometers east and 5 kilometers north of the point of origin. The resultant displacement, as we now know, is represented by the arrow labeled D. The magnitude or length of D can be obtained using the theorem of Pythagoras because D1, D2 and D form a right triangle with D as the hypotenuse. Thus D2 equals under root D1 squared plus D2 squared, which is under root 10 kilometers squared plus 5 kilometers squared, and that is under root 125 kilometers squared. Square root of 125 gives the answer 11.2 kilometers. If you want to know how to find square roots like this without using a calculator, then I've got a video on it that I'll link down below in the description. But you can use Pythagorean theorem only when the vectors are perpendicular to each other. What if the vectors are inclined at another angle? For this, we will use a formula that we won't derive here. The formula is this: the magnitude of resultant of two vectors a and b, which is denoted by r, is equal to under root magnitude of a squared plus magnitude of b squared plus 2 times magnitude of a into magnitude of b multiplied by cosine of angle between them. To use this formula, we should know how to calculate angle between two vectors. To find angle between two vectors, both the vectors are drawn from one point in such a manner that arrows of both the vectors are outwards from that point. Now, the smaller angle is called the angle between the two vectors. For example, in this figure, it seems as if the angle between the two vectors is 120 degrees, but that is misleading. To calculate the angle, we must move the vectors such that their tails join each other and their heads are pointing outwards. Then we can see that the angle between the vectors is actually 60 degrees and not 120. In this formula, we can easily observe that if the angle theta between vectors a and b is 0, which means if the vectors are parallel, then r is a plus b, and this is the maximum value for magnitude of the resultant. If theta is 180 degrees or the vectors are antiparallel, then r equals a minus b, which is going to be the minimum value for r. And if theta is 90 degrees, then we get r equal to under root a squared plus b squared, which is just the Pythagoras theorem. Sometimes we might need to find the angle of resultant vector with the vectors that form the resultant. For that, we use the following formulas. If alpha is the angle between vector a and resultant r, then tan alpha is b sine theta divided by a plus b cos theta. And if beta is the angle between b and r, then tan beta is a sine theta upon b plus a cos theta. Here, obviously theta is angle between a and b. If we want to find the magnitude of the subtraction of the same two vectors a and b, then the formula is under root magnitude of a squared plus magnitude of b squared minus 2 times magnitude of a into magnitude of b multiplied by cosine of angle between them. So the difference for subtraction is only of the minus sign here. The rest of the formula remaining the same. For finding the direction of this resultant S, you can use the following formulas. It's also important here to know some properties of vector addition. The first one is that the order of addition does not matter. Adding a to b gives the same result as adding b to a. So a plus b equals b plus a. This is known as commutative law. The second property is that when there are more than two vectors, we can group them in any order as we add them. Thus, if we want to add vectors a, b and c, we can add a and b first and then add their vector sum to c, or we can add b and c first and then add that sum to a. We get the same result either way. This is called as the associative law. So that's our video on vector and vector addition. In the upcoming videos, I'll also cover the topics of vector components and vector multiplication. If this video helped you understand vectors better, consider subscribing for more maths and physics videos.